So multiple choice topic 7, working these together. Number 120. JD, you said B is not right?
Yes.
I agree with that. Why is B not right?
Because the y is BX.
Right. It's like the algebra is fine, but they didn't separate it. So B is out. What answer do we like? A? I like A as well. C and D, they made algebra mistakes. Like, that's not even a calculus issue. That's... So yes, it's A. All right, gentlemen. A particle moves along a horizontal line so that its velocity is given by, at time 1, the particle has position, find the position. So this is position, velocity, acceleration, where you take a derivative to get that way and an antiderivative to go up the chain. So it gives me velocity, and it asks me for position. So what do I have to do to get from velocity to position? Antiderivative. So I'm going to antiderivative velocity, and that should get me something having to do with position. There's kind of two ways to work this problem. Let's see, at time 1 it's at 4. Find the position at time 2. Okay, method 1. Take the antiderivative of velocity, you get a plus c, and then use this first piece of information to figure out what c is, and then plug in time 2. Straightforward, nothing wrong with that. Another option, though, would be to use 1 and 2 times 1 and times 2, and then I can skip finding c. Whoops, not plus, but minus. And I'm looking for s of 2. I know s of 1. So I'm going to do it that way, because it bypasses figuring out what c is. So I'm still going to have to integrate, but that should say minus. Top one minus the bottom one. But rather than finding c, I'm going to sort of bypass that step and just plug in top minus plug in bottom. That tells me S2 minus S1. I know S1, I can find S2. Okay, so now I just need to got the big picture down. Now I've got to do the calculations for derivatives or antiderivatives, I guess. So Noah, how about the antiderivative of negative 12t squared?
Negative 4t.
Negative 4t cubed. Ethan, the antiderivative of 36t?
Just 36. Wait, no, that's derivative.
Yes, you're right.
So it'd be t squared.
Uh-huh.
And then 18, right?
Good. And then that's kind of the order you would do it. You would increase the power by 1 and then divide by that 2. And then we want to plug in 2 minus plug in 1. I'm guessing this is a no calculator question because those are relatively simple things to plug in. So plug in the 2. Negative 4 times 8 plus 18 times 4. Minus plug in the 1. Let's see, that's 32, negative 32 plus 18 times 2 is 36, times 2 again is 72. So that first one's 40. 18 minus 4 is 14. 40 minus 14 is 26. I was kind of surprised that wasn't one of the answer choices. It's not right, but that's how far it changed from 1 to 2. If you integrate a rate, you get an amount. So we changed by 26. S of 2 is what we want. S of 1 is 4. So add 4 to the other side and get 30. Another way to sort of rearrange that equation is that you started at S of 1. You added some change in amount. and that landed you at S of 2. But most people start with that because that's the easiest, straightforward way to start. All right, 122, back to a differential equation. This one's already separated, so why don't you do the differentiation, the antiderivative part, the integrate part, and pick an answer. All right, so that one was A. 123. This one, we're going to have to separate and integrate and plug in the point. So this is going to be like all of the steps. So I'm going to put e to the y on the y side, which makes it e to the negative y. Multiply dx over. So there's my separate step. Then comes the integrate step. So let's pick on some people for the integrate step. Yeah, I got the 2 JTs in the class. Jackson, how about the antiderivative of e to the negative y? It is sort of e to the negative y. But there'd be a chain rule thing, right? Check it by going backwards. If you took a derivative of e to the negative y, you'd get e to the negative y, but you'd also get a negative 1 on there. So you need a negative on there. Is that what you said?
I said negative e.
Oh, okay, I didn't hear the negative. Sorry. JT, how about the other side?
Just x dx.
It is just, well, the antiderivative of 1 is x, but that you don't need the dx anymore because that was part of the antiderivative process.
Come on, rugby boy. Come on.
I'm waiting for you to give me the rest of that.
Plus c.
Plus c. Okay, so now I start looking for my answers, and nothing matches exactly, but if I move the negative over, now I'm kind of close to C. In fact, well, I need to see if 0, 1 works, or 1, 0. So I'm not going to solve this for y, although I may need to in a minute to figure out if it's A, B, or D, but it kind of looks like answer choice C. So I'm going to plug in 1, 0 now. So e to the 0 equals negative 1 minus c. Oh, that's a c, not an e. E to the 0 is 1. Add the 1 over. I get c equals negative 2, which works because this is minus negative 2. So it is c, and I didn't really have to solve for y. This is kind of an ongoing theme of when should I plug in the point to figure out what c is, because you can solve for y and then do it, or you can do it as soon as you integrate, and it kind of just depends on the problem, which would be a better choice. 24. That looks, well, it kind of looks like inverse sine, but it also kind of looks like a u substitution. So which one should we do? Or which one do you want to try? Well, I think we should try u sub and see if it works, and maybe you know it's going to work, because like anytime you do u substitution, you're picking u so that du shows up, and sure enough, du almost shows up. But Gabe, what do we need to do to make it work? There we go. I just wanted to hear you say spawn a 2. So let's see. I put a 2 there. And then a 1/2 out front. So y equals 1/2 antiderivative u to the negative 1/2 du. Because I don't want to integrate roots, and I don't want to integrate things in the bottom. I want a power so that I can use the power rule. So, Parker, how about I'll leave the 1/2. What's the antiderivative? What's this part of u to the negative 1/2?
2u to the 1/2.
Very nice. Increase the power by 1, divide by the new power. Don't forget the plus c. So y equals the square root of 9 plus x squared plus c. Let's see, does that look like any of my answer choices? It looks like A. Also looks like B if c is 0, so I better be careful. But there's not a 2 or a 1/2. You can easily see where those mistakes would have come from with all the 2s and 1/2s we had in there.
Where did the 1/2 go?
So, which 1/2? This 1/2? Well, when we took the antiderivative, that 2 came from the antiderivative. And then these two things combined to go away. So now I just need to figure out which one of those works for 4 or 5. 5 goes in for y. 4 goes in for x. And c equals 0, so that means it's B. $125 is awful looking. F prime equals 2 times f. And f of 2 equals 1. I suppose you could like work backwards and plug those in and see which one works.
Can't you take the derivative?
What do you mean, the derivative of like each of my answer
Can't you
choices?
take a derivative of the f? Like, can't you take a derivative of those two? And then chain the second one? Or not chain, multiply rule, whatever it's called.
If I take a derivative of these two, that's going to tell me that the second derivative equals 2 times the first derivative.
Or antiderivative, sorry, antiderivative. Usually.
Okay. Yes, I can antiderivative f prime to get to f. But then I've got f equals f, or f plus c equals 2f.
Oh, yeah, no.
What's another way to write f, or f prime? How could I rewrite f prime? dy dx. And what's another way to say f? Y. And then I think this looks a lot better. I think that I can separate and integrate. So dy over y equals 2 dx. Two lucky winners here.
Yeah.
Olivia, what's the antiderivative of dy over y? Thomas, who has a derivative of 2?
2x.
2x. 2x, I need you to say a little more.
Oh, plus c.
Plus c. Okay, that's not what I want yet because I need to solve for y. So we do the fishhook thing, the loopy thing. So e to the 2x plus c equals y. But there's also that other trick where it's c e to the 2x. So all of those answer choices like sort of fit the. Actually, D doesn't fit the format. It's one or the other. There's either something in the exponent or something out front, but not both. So I think I can throw D out. I don't know which one it is, so I'm going to start with this one and see what happens when I plug in 1, 2. Oops, not 1, 2, but 2, 1. So 1 goes in for y equals e to the 2 times 1 plus c. Wait, 2 times 2. Keep getting my x's and y's backwards here. 1 equals e to the 4 plus c. Okay, solving that for c, like with algebra, is that we're a few steps away. But let's pause here. E to what power would get me 1? 0. So what does c have to be? Negative 4. So y equals e to the 2x minus 4. And that's answer choice B. Goodness, that one had all 3 steps, right? Separate, integrate, solve for c.
You plug the X's and Y's in.
Slope fields. Why don't you try 26, the first one up there? Just matching. And I'll remind you that a lot of times just, does it depend on X? Does it depend on Y? Does it depend on both? That can really narrow things down. It's been a rough day recording. So there's the answers to those. Next, try the next 2. It's still matching with slope fields. And again, think about, or I'll say this, for 127, definitely think about depends on X and Y, and then you may just have to plug in some points. It is changing left and right. It's not changing up and down. And then in that second one, I would say the signs in quadrants. So if it changes left and right, it's got to depend on X. And it doesn't change up and down, so there can't be any Y stuff in it. So D and E are out. I'm going to pause. You finish it. This is still better than second period's effort. So 27, if we... so we ruled out D and E because it didn't depend on Y. And then someone said, if you looked at X equals 0, I need to have a negative slope. All right, when X is 0, I need a negative slope. That would rule out C and rule out A, so it would have to be B. For 28, you could just pick points if you wanted to, but right away you can see that it's very quadrant heavy. So if you go quadrant 3, X is negative, Y is negative, and yet the slope is negative. So you got to figure out which one of those combination of things could work. First of all, C is always positive, so he's out. D, negative over negative, would be positive. That's out. B, negative over negative, would be positive. And so, not that you would jump straight to quadrant 3, but if you jump to quadrant 3, you would get your answer quickly. Otherwise, you're sort of picking points. I definitely would have, because of all the signs, I would not have picked anything in quadrant 1. I would have picked somewhere else and started working from there. Because in quadrant 1, everybody's positive, all of these are positive. That doesn't really get me anywhere. All right, 129. I think this is a calculator problem. And this is a long problem because this requires all of the steps. A population of shrubberies increases at a rate proportional to the square root of the population. A population of shrubberies increases proportional to the square root of the population. Dylan, tell me something that you learned from that first sentence. Something mathy. You can give me the whole equation if you want, but for this first sentence, what do we learn from that?
The rate is proportional to the square root of the population.
Okay, so what does that mean in terms of math? Give me something mathy I can write down. Stop it, Brayden.
It's something K, right?
Okay, that'll work. There's something K involved there.
K equals the square root, right?
And the square root of something. We're getting there. You can let somebody else hop in. Vito, give me some more information. Okay, we're close. I like square root of p because it's square root of the population. So there's square root of p. But on the other side, it increases at a rate. So the other side isn't p. What's the other side? Anybody? dp dt. dp dt.
Oh, I forgot because K is.
Alright, the second statement or the second sentence. If the population goes from 2,500 to 3,600 in 5 years, what is the population at the end of 16 years?
K is.
So I need to separate, integrate, find C and K, and then plug in 16. So we're up. This is yuck. Square root of p. What does that become when I move it over? P to what power?
1/2. No.
When I move it over to the left,
Oh.
it'd be negative 1/2. Skipping a lot of steps there. 'Cause it's p to the 1/2 on the right, divided over to p to the negative 1/2. There's my separate step. Now to integrate. Bo, you got the easy one. Should have given Bo the hard one. Isabella, what's the antiderivative of p to the negative 1/2? 2p to the 1/2. Increase the power by 1, divide by the new power. Bo, how about your side? The antiderivative of k dt? Or k times the antiderivative of 1 dt, if that helps. What has a derivative of 1? X, or t in this case. So kt plus c. Okay, I've got 2 pieces of information. That will help me find k and c. Then I'll plug in 16. This is the point where we got to earlier, where I can solve for p, and then I can plug in, or I can plug in first and then solve for p later. I think you avoid some algebra if you plug in now. So it doesn't look great, but that's okay. I think let's plug in now and maybe save ourselves some algebra headaches. So 2,500 in for p. Zero in for time. Wow, they were nice here. Square root of 2,500. 50 times 2 is 100. So C is 100. All right, next let's plug in 5 and 3,600. 2 times 3,600 to 1/2 equals k times 5 plus 100. 60 times 2 is 120. Minus 100 is 20. Divided by 5 is 4. So k is 4. This is a really long multiple choice problem. And now I want t to be 16. So 2, p I don't know, k is 4, t is 16, c is 100. Surely this is a calculator problem. Maybe not. 16 times 4 is 64, plus 100 is 164, divided by 2 is 82. And then I need to square 82. Well, that's doable without a calculator. Probably not your favorite thing, but so what is that? 6724. That would have been easier with a calculator. Yeah.
I'm sure you tried that.
All right, 130. Separate and integrate. dy over y equals x squared dx. Pick on two more people, and then we'll be. Lucas, how about the antiderivative of dy over y?
Is that line blank?
Natural log of y, but I knew what you meant. And Ben, how about the antiderivative of x squared?
1/3 x cubed plus c.
Plus c. And then this could be means we don't actually have to solve for c. Let's see, let's do the e to the stuff. So y equals e to the x cubed over 3 plus c. But that also means it could be c e to the x cubed over 3. So a's out for sure. B has the plus 7 in the wrong spot. The plus 7 would need to be in the exponent. C looks good. D, I don't know where that came from. So C it is. And that leaves you with one to do on your own.